Next up is Richard Padley, the Managing Director of Semantico. He's going to talk to us about taxonomies and, as an example, one that Semantico prepared for McGraw-Hill's Access Engineering product.
Thank you, Terry. Okay, so I'm going to tell you a story. In the beginning, there was a page-turning ebook library from McGraw-Hill, contained 350 key titles for engineers. The downside was that everything online was structured around the printed page, and that was the kind of methodology that had been used to build the website. Part of the brief we had was we weren't going to use the word ebook, and we weren't going to use any page turning. Therefore, the concept was to liberate the content from the sort of bound-up nature of the pages of its format. So there were all kinds of interesting things we wanted to think about. The stuff that we normally get involved in, like business models and user experience and search results and data transformation. But to fulfill this particular brief, we knew that the books were going to have to work much, much harder. So the existing site was perceived by users as flat. The search results didn't show the depth or richness of the content that was there. Out of the brief came the idea that we needed to be better at surfacing the content that was contained in the collection. So we needed to build a taxonomy. We started off by analyzing the content. We had about 88,000 chapters, 121,000 figures, tables, graphs, and videos. There's a lot of rich content in there that was hidden inside this kind of page-turning model. So we know then we wanted to build a classification system, and we wanted it to work well on the web, so it needed to be a faceted classification. We wanted users to be able to drill down through search results without having to go to an advanced search page to do that kind of thing. The model that we chose was called PMEST. It comes from the field of library sciences. There are 5 facets, and this is an example of how a research paper might be classified using those facets. So this was the conceptual framework that we adopted at the beginning of this project. In our design also, we wanted to make some simplifying assumptions. We decided to avoid this concept of polyhierarchy, which is where you have multiple parents, because when we wanted to drill down or up the tree, we wanted a consistent view of larger or smaller numbers of choices. This is a tool called Protege. It's an ontology editor. This is what we use for building the taxonomy. It's what we use for prototyping as well. If you're going to do this activity, don't use a spreadsheet. That's definitely a fire hazard. We did some prototyping work to start off with. This is where we started off, if you like. This was the kind of the straw man: subjects, materials, process, places, and dates. That was the kind of starter for 10. We did some testing. We hand classified about 100 items. Then things started to get a bit clearer. We knew that we didn't need place or date. They didn't really make sense with the content that we were classifying. And material started to look like it was going to be too much effort to justify it. And we thought of another way of getting around that particular issue. So one thing I want to say is we didn't want to reinvent the wheel here. We wanted to reuse as much as possible. We wanted to stand on the shoulders of giants. We ended up reusing some of the terms and structure from the IET thesaurus as building blocks. And in order to get those candidate terms into the thesaurus, we indexed the content. We tagged and extract entities from that. We built a list of candidate terms which we then matched against the thesaurus to evaluate, to see which ones we wanted to populate the taxonomy initially. There was an iterative process for the editorial side of things, where once we populated those terms, there was a batch of content which was tagged. That led to the discovery of new candidate terms. These were validated by subject matter experts who then checked back against the taxonomy to populate more terms in there. We turned that taxonomy over to the subject matter experts and let them build out the remaining levels and tag all of the content. So there were several rounds of iteration, as I explained, so that we could allow the structure to be enhanced as part of the tagging process, so it wasn't static. We designed a data architecture that let us keep the data sources separate so that the actual terms and structure and the classification data points were separate from the XML chapter files. That let us update the terms and structure without having to go back and re-tag into all of the article files. This is how it turned out in the user interface. We did a search, here we go, for carbon steel, and you can see on the left-hand side there we have filter by subject. We've got titles. Those are obviously generated automatically from the metadata. Way down at the bottom there, we've got filter by type. That'll come up in a second. You've got those types. That's what was our solution to the materials facet. We generated those automatically again from metadata. And processes, tagged again by the taxonomy. So we were really pleased with the way this turned out. And wrapping up now, the takeaway was that the brief and the business case was really, really important to keep us all focused on this particular small element of the project. Big increase in usage, big increase in sales, pros award winner, and no singed whiskers. Thank you.